how it is that we could be asked uh, to find an antiderivative. So the first question asks, it says find a function whose derivative is this right here. So it's basically asking find an antiderivative of this thing right here. And what that rewritten, we could say find an antiderivative, and we write the antiderivative symbol saying find the antiderivative. Find an antiderivative of this right here. And we could write it like that. And that maybe makes it a little bit more clear to us, right? This just means find the antiderivative with respect to x. And now what you can do is you should see that you really just want to find, first, you want to break it up into its pieces, right? Into its terms. So 3. What function, when I differentiate, do I get just 3? Well, if I differentiate 3x, I just get 3. Now the question is minus. What function, when I differentiate, do I get 4x? Well, I could take out the 4, and then I could ask myself, what function, when I differentiate, do I get to get just x, right? And the way you kind of do this is you take out that 4, and then you think the antiderivative x, right? So the antiderivative x to the 1, right, is equal to 1 plus 1 on the top as an exponent divided by that same value. And then, of course, plus c, but we'll deal with the plus c at the end here. So it's going to be x squared over 2. And that you just put right here. X squared over 2. And the 4 and the 2 can cancel, but we'll do that at the end again. Plus 2 times an antiderivative for cosine x is just sine x. And now I'm going to put the plus c, and I'm just going to rewrite it just to deal with that 4 over 2 minus 2, right? Minus 2 x squared plus 2 sine x plus c. And this is the general one. It says find any function, so I didn't even really need to put that c, but the, this is all the functions are of this form with the plus c here, and you want to check, right? If I differentiate this function, this is my answer right here, right? And and it asked me to find a function whose derivative is this. Well, let's see, is the derivative of this thing the original one? And you can check. What's the derivative of 3x? Just 3. What's the derivative of negative 2x squared? You bring down the 2, and you get negative 4. The exponent goes down by 1 to x to the first. And then the derivative of 2 sine x is 2 times the derivative of sine is cosine. And then the derivative of a constant is 0. And now we should see that this is the derivative of this function, this? Yeah, I got back the same thing. And that's the idea behind anti-differentiation. Now, similarly, it could just go straight into asking us something like this. Find the antiderivative of 8 minus 4x cubed plus the square root of 5 cosine times cosine x dx. And again, you want to integrate it in pieces. Or you want to integrate, or you want to anti-differentiate, I should say. You want to anti-differentiate in pieces. So the antiderivative of 8 is just 8x. The antiderivative of negative 4x cubed. Well, that's negative 4 times the antiderivative of x cubed, which is x to the 4th. I increase the exponent by 1 and then divide by that same value. And these 4's will indeed cancel, plus the square root of 5, that's just some constant. And what's the antiderivative of cosine x? Sine x. And again, let's check. Let's do the plus c, and then let's check. So this is my answer. I have 8x minus x to the 4th plus the square root of 5 sine x plus c. And I say that this is an antiderivative for this right here. This is an antiderivative for this right here. And what does that mean, right? Again, it means when I write this symbol, when I write that integral symbol, right, I'm looking for the antiderivative of this function, that I'm looking for a function whose derivative is this, right? Whose derivative? I want a function whose derivative is this. Here, I say, is my answer. Is the derivative of this function this function? Let's see. The derivative of 8x is 8. The derivative of x to the fourth is 4x to the third. I keep the minus. The derivative of sine x is cosine x. The square root 5 just comes out. And then the derivative of c is 0. And now I have back the inside. Again, I found an antiderivative for this whole thing here.